Okay, so the first one we're going to talk about, which we are very familiar with, is dots. And we all know that dots stands for the difference of two squares. So up until this point, I've done very basic dots with you. And it's not that it ever gets so intense. It's just, bigger, I guess. So we know if we have an a squared minus b squared, we are going to factor this into an a plus b times the quantity of a minus b. But no matter what do we always look for first? No matter what kind of factoring it is? Okay, the GCF. All right, so let's look at our first example. If I have 4x squared minus 100, even though you might look at this and be like, okay, it's two terms, so I'm thinking dots. I have 4x squared is a perfect square. I have 100 is a perfect square. We can dots this right away. You can't dots this right away. Why not? Why can't we dots this right away? Philip?
GCF.
Good, because we can take out a GCF of 4. Once we take out that GCF of 4, we're left with x squared minus 25. Now we never think we're done. We look inside our parentheses. Is there anything else I can factor? Absolutely. The x squared minus 25 becomes x plus 5, x minus 5. Say I have 36 x to the 6th minus y squared. We know 36 is a perfect square. X to the 6th is a perfect square. Why is x to the 6th a perfect square? What times itself gives us x to the 6th?
6x to the 3rd.
I'm sorry, say one more time.
6x to the 3rd.
You got it. X to the 3rd times x to the 3rd is x to the 6th. So 6x to the 3rd is basically the square root of this. And we know y squared is a perfect square. So when we go to factor this, we are going to have 6x to the 3rd plus y, 6x to the 3rd minus y. Does the order of the parentheses matter? Like, for example, if I put the quantity of 6x to the 3rd minus y first, does it matter? No, multiplication is commutative. It doesn't matter which parenthesis is first. Okay, let's say we have a to the 8th minus 16. Anybody? Anybody at all? Oh, okay. What's up?
For number 2, did you have to like factor out like the square? Have it, like,
A square of what?
Like kind of put the whole like thing under group and have like 6x to the 3rd minus y, like in parentheses to divide the square.
No. Okay. Great question. So if you were to do that, these are not the same. So if you had 6x to the 3rd minus y squared, wouldn't that be 6x to the 3rd minus y times the quantity of 6x to the 3rd minus y? If we double distribute this out, you're going to get 36x to the 6th, which matches up, right? But then you're going to get negative 6x to the 3rd y, then another negative 6x to the 3rd y, and then a positive y squared. Negative y squared, sorry. A negative y squared. These do not cancel. So this would have been 36x to the 6th minus 12x to the 3rd y minus y squared. Not the same. So the reason we need 1 plus and 1 minus is so that middle term cancels out. So if you just take it and square it, you're essentially like doubling this middle term. Tori?
Say that 36, say it wasn't a perfect square, it was just a one, but you still had x to the 6th. You couldn't do that, right?
Nope, you could not. Okay, let's look at number 3. A raised to the 8th power minus 16. Does this fit the format for dots? Absolutely. We are going to get a to the 4th plus 4, a to the 4th minus 4. Am I done? No. Why am I not done? Danny.
A to the 4th minus 4 can be factored again.
Good. A to the 4th minus 4 can be factored again. That's another dots. So that gives us a squared plus 2, and then another quantity or a different quantity of a squared minus 2. Is there anything else I can factor here? What about a to the 4th plus 4? No, we cannot. This is it. So here we have x to the 2m minus 4. Is x to the 2m a perfect square? Yeah, what multiplies to it? X to the m. So this is x to the m plus 2, x to the m minus 2. All right, I have a couple I want you to try. You all try. So the directions are obviously two-factor. Directions are two-factor. All right, who has factored the first one? Tell me your final factored form. Tejas.
5 times the quantity of x squared plus 1 times the quantity of x plus 1 times the quantity of x minus 1.
That is perfect. Anybody want to see me do this? Okay, number 6. Someone tell me what you get. Michael.
2x squared plus 5y times 3x squared minus 5y.
Perfect. Anybody want to see me do this one? All right, let's move on. We're still in dots. All right, this is a dots. I have this whole quantity squared minus, and then a perfect square, right? 25, 5 times 5 is 25. So this whole quantity is being squared, which means it's a perfect square. And then this is 25 and a minus in the middle. So what we're going to do is the same way we would have done it if it were x squared minus 25, right? You take our first part of this, and we're going to write x plus 5 in one parenthesis, and then an x plus 5 in the other parenthesis. Then we're going to have 1 plus and 1 minus, and then the square root of 25 is 5, so then a 5 and a 5. But we're not done. Why are we not done? We can combine our like terms, right? So if I have a positive 5 and a negative 5, what happens there? They cancel. If I have a positive 5 and another positive 5, isn't that 10? So now in the second parenthesis, it's just x. And in the first parenthesis, it's x plus 10. So this is the factored form. Okay.
Why didn't you distribute?
Why didn't I distribute what?
Oh,
The quantity of x plus 5 squared?
I got it now.
Are you sure?
Because it's like problem 5 too, where you pull it out and then it stays there. You know?
No, I don't know what you're saying. But be careful, because we're trying to factor. We're not trying to simplify. So my directions are not to simplify. If my directions were to simplify, we would 100% have to multiply this all out. But because I'm asking you to factor, and I'm looking at this, I'm like, oh, this is a great dot scenario. I can try to factor this, because this is a perfect square, there's a minus, and then this is a perfect square. Did I answer your question?
Yeah.
Okay. All right, let's do another one. Let's say I have x squared minus the quantity of y minus 2 squared. Remember, our directions are to factor. Does this fit a dots? Absolutely, but we want to be very careful with this. So do we agree the first part of each parenthesis is an x? Now we're going to have 1 plus and 1 minus. And then I'm going to have y minus 2. In the plus, it's good. Y minus 2 is fine with the plus. But now for the second parenthesis, when I'm subtracting, I'm not just subtracting the y. Aren't I subtracting that whole quantity of y minus 2? So what do I need? Parentheses to show I'm subtracting that whole quantity, so the minus gets distributed. If you want to just immediately distribute that minus, you can. So then in the first parenthesis, nothing changes, x plus y minus 2. In my second parenthesis, it's x minus y plus 2. And this is our factored form. Danny?
Would it not have been factorable if it was x squared plus like parentheses of y minus 2 squared?
It would not have been, no. Well, it wouldn't have been a dots. At that point, it still wouldn't have worked. Even if we double distributed and combined like terms, it still wouldn't have worked. There wouldn't have been anything to factor. Okay, next one. You guys tried these two on your own. Actually, it's just one. You guys try this one on your own. All right, someone tell me, what did you get? Noah?
R minus 5 minus 8x minus r minus 5 plus 8x.
Yeah, you got it. Perfect. Anybody want to see me do this? We're good? Okay. All right, let's talk about now. So we talked about the difference of squares. Now we're going to talk about the difference of cubes. Actually, there's difference of cubes and there's sum of cubes. So let's make two little headings here. So we have difference of cubes. And then we will also talk about the sum of cubes. All right, when we have a difference of cubes, we will have some expression raised to the third power minus another one raised to the third power. And when it comes to factoring the difference of cubes, it will always fit the same format. So you know how a difference of squares, a dot, is always like a plus b, a minus b? Right? This is always going to be, when it's a difference of cubes, a minus b. And then the next one is actually a trinomial. It's going to be a squared plus ab plus b squared. And I'm going to show you, you don't need to write this part, but I'm just going to multiply this back out to show you that we will end up getting a cubed minus b cubed. So a times a squared is a cubed. A positive a times a positive ab is a positive a squared b. Positive a times a positive b squared is a positive ab squared. All right, negative b times a squared is a negative ab squared. Negative b times ab is a negative ab squared. Negative b times a positive b squared is a negative b cubed. When you come to combine your like terms, these cancel. Oh, wrong ones. Sorry. Try that again. There we go. Where did my a squared go? Did I write it on squared on the wrong one? It should have been a squared b. Did anybody see where I wrote the wrong exponent? The first green? Thank you. This should have been the a squared b. Yep, that should have been the a squared b. All right, so now we're going to have a squared b and then the negative a squared b. That cancels. And then we have ab squared and the negative ab squared. That cancels. So what are we left with? A cubed minus b cubed, which is what we had started with. So anytime you have a difference of cubes, this is how we go about factoring it. So we said a minus b times the quantity of a squared plus ab plus b squared. Do you think you need to memorize this? Yes, you need to memorize this. All right, yes, Philip.
Switch the sign, so you'd be like a plus b times a squared minus a.
No.
Okay.
No.
So the trinomial always has to be positive.
For this one, the trinomial is positive. Yeah, no, you don't want to do that. So I see what I guess technically you could if you wanted to like pull out the negative. If you wanted to pull out a negative, then this would be a plus and then all of these would be negative, but why would you do that? Okay, let's keep going. So now we're going to have, for the sum of cubes, this is a cubed plus b cubed. The format is now different. If we're going to factor this, this is now going to be a plus b. So when it was difference of cubes, your first quantity was a minus b. When it's sum of cubes, your first quantity is a plus b. And now the trinomial, a little bit different, is going to be a squared minus ab plus b squared. Do you need to see me multiply this back out to prove to you that it works? Or are you good? You believe me? Believe me? Okay. So let's do an example. Let's do some examples. So let's say I have x cubed minus 8. Well, do we agree this is the same as saying x to the first raised to the third power? And 8 is the same as saying 2 raised to the third power? So is this a difference of cubes? Yes. So here, our a is x and our b is 2. Our a is x and our b is 2 because we have x to the third minus b to the third. A to the third minus b to the third. And when we have that, we're going to end up with an a minus b times the quantity of a squared plus ab plus b squared. And now we know our a is x, so this is x minus 2. A squared is x squared, ab is 2x, b squared is 4. Okay. I can't hear you. Could you speak a little louder?
Oh wait, never mind.
Are you sure?
Yeah, I was gonna ask
If you could factor that?
Yeah, but you couldn't. I got them mixed up.
Yeah, so this isn't 2ab. If this was a 2ab, then it would have been a perfect square trinomial, but it's not. So this cannot be factored. There's no factors of 4 that add to 2. And I don't think any ones I give you show up where this can be factored. I'm not. I'll never say never, but I'm pretty sure. Okay. Let's keep going. So that was a difference of cubes. Let's say I take the same thing, but now I put a plus sign in there. This is now a sum of cubes. Well, this is x to the first raised to the third plus 2 raised to the third. So once again, my a is x, my b is 2. But for the sum of cubes, it's not a minus b anymore. Now it's the quantity of a plus b times the quantity of a squared minus ab plus b squared. So now we just sub right in x plus 2, and in our second parenthesis, it's x squared minus 2x plus 4. Can I keep going? All right, let's say we have 8x to the third minus 27. So when we're dealing with the cubes, we're saying what times itself 3 times. That's what we're doing. What times itself 3 times gives us this. So what times itself 3 times gives us 8x to the third? James? 2x, right? 2x, that quantity raised to the third gives us 8x to the third. What about 27? What number times itself 3 times gives us 27? Alexandra? 3. So this is 2x cubed minus 3 cubed. So what does that mean for us? Our a is 2x. What's our b? 3. So this is going to be a minus b times the quantity of a squared plus ab plus b squared. And now we just sub right in. So we are 2x minus 3 and then 4x squared plus 6x, right? AB is 2x times 3. 2x times 3 is 6x plus 9. If I'm going too fast or you don't understand how I got something, please stop me. Tejas?
Why would it be 6x?
Why would it be 6x? Because of this right here. You multiply A times B together. So our A was 2x and our B was 3. So 2x times 3 is 6x. Any other questions for me?
Can I go to the bathroom?
Sure, could you just do the whole pass, please?
Yes.
All right, let's keep going. So I'm going to have 1,000 x to the 6th plus 27 y to the 3rd. You guys try this one. 1,000 x to the 6th plus 27 y to the 3rd. All right, what are we still working or are we done? What'd you all get? Somebody new, somebody new. What'd you get? What'd you get? Kai, you're not new. Somebody new, somebody new. Somebody bring the energy. Oh, hi. I want to say Bridget.
Yeah.
Yay.
10x squared plus 3y times the quantity 100x to the 4th minus 30x squared y plus 9y squared.
Yay. It's perfect. Anybody need to see me do this? Don't be shy. All right, let's keep going. Okay, so the next part of this is grouping. The next part of this is grouping. And in the past, I used to wait until the second lesson in this to sort of summarize all the different grouping options. But I think it might be beneficial to do it first, so then you guys can sort of address it as you're doing problems. You'll understand what I mean once I start writing. Okay, so there's different categories of grouping, and we categorize the different grouping options based on the number of terms in the original. So let's say our original is 4 terms. So if our original is 4 terms, we can group it in a 2 by 2, meaning group 2 terms together and then another 2 terms together. That's what I mean when I say a 2 by 2 grouping. So group 2 terms together and then another 2 terms together. And that's going to be called a sort of GCF grouping. And I'm going to give you an example. So if I have 6, let's say I have, do I want to distribute this in? Yes, let's say I have 6x minus 6y plus 5cx minus 5cy. So this is clearly not our traditional type of factoring, right? Normally when we have factoring, we have an x squared, we got something else, we got a third term. This is not our traditional type of factoring. But what I'm seeing is I'm seeing some like variables. I see an x and a y, I see some c's here. What we're going to do here is we're going to group two terms together and another 2 terms together. But essentially what we're doing when we're grouping the terms together, we want to be able to pull out a GCF so what's left in the parentheses in the first group and the second group is the same. So it's the same expression left in the parentheses. So right here, if I group these 2 together, right, I can pull out a 6. Do you agree? If I pull out a 6, what are we left with?
6 times x minus y.
X minus y, not 6 times the quantity, right, of x. We'd be left with an x minus y, right? If I group these 2 terms together and I pull out a 5c, what am I left with? X minus y. Are they the same? That's what you want. So when you do a 2x2 grouping, after you pull out each GCF, you want it to be the same thing in the parentheses. So that's what we're going to do. We're going to group these together, and we're going to group these together. All right, so in the first one, I'm going to pull out a positive 6. And then I'm left with x minus y. All right, in the second one, I'm going to pull out a positive, that should have grouped it like that. I'm going to pull out a positive 5c. And then I'm left with x minus y. Do you guys agree this is sort of like a binomial? One term, because this is all multiplication, then a plus, then another term, because this is all multiplication. So now, what I'm going to do here, this is thinking of looking at it like a binomial. Can I pull out another GCF? Yeah, can I pull out a whole quantity of x minus y? That's what I'm going to do. I'm going to pull out the whole quantity now of x minus y as a GCF. When I pull out that whole quantity of x minus y as the GCF, what am I left with?
5c plus 6.
You got it, 5c plus 6, or 6 plus 5c, addition's commutative. And this is our 2x2 grouping. All right, so the first type of grouping was the 2x2. The second type for 4 terms is a 3x1. Let's change up the color here. It is a 3x1. All right, now in a 3x1, we try to make a quote-unquote dot scenario. Okay, what does that mean? So when I have a 3x1, I have, let's say I have x squared plus 4x plus 4 minus 9c squared. So when it was a 2 by 2, it meant group 2 terms together and then another 2 terms together. What do you think a 3 by 1 means? Group how many terms together? 3, exactly. I'm going to group 3 terms together and then leave 1 term out on its own. So when we're in a 3 by 1 scenario, you want it to almost end up like a dot, some quantity squared minus a perfect square. That's what you want. You want to turn this into a dot. So what we're looking for is a perfect square trinomial. So I'm going to write star, look for a perfect square trinomial. Does anybody know the format of a perfect square trinomial? Anybody know what that is? Okay.
Where
Like a squared.
the two numbers, or actually, if the number at the end, the factors of that square at the end add together to make the thing square.
Yeah, you're on the right track. You're on the right track.
I can't put it into words, but
There's like a sort of like a formula type. Noah?
It would be like a squared plus 2a x, well, no,
B.
and then b squared.
Then b squared, you got it. So it's a squared plus 2ab plus b squared. This could also be a squared minus 2ab plus b squared. Those are perfect square trinomials, meaning if you were to factor this, it would end up being an a plus b squared. That's what it would look like. So looking at our problem, this is a perfect square trinomial. Why is this a perfect square trinomial? If I were to factor this, wouldn't this end up becoming the quantity of x plus 2 squared? Right? If we factored x squared plus 4x plus 4, this is a perfect square trinomial. So what you're going to do is you're going to group together the perfect square trinomial. And then you're going to factor it. So I'm taking x squared plus 4x plus 4. I'm going to factor this. That's going to be x plus 2, the quantity, squared. And then aren't we left with minus 9c squared? Isn't this a dot? We did one similar to it earlier in the period, right? So now we factor our dots. This is going to become an x plus 2 minus 3c and an x plus 2 plus 3c. Okay, so we're still talking about original 4 terms, right? So we have our 2 by 2 grouping. We have a 3 by 1 grouping. Our last one is going to be, for 4 terms, is going to be, what color should I use? Have I used blue yet? Yes, I used blue. Let's use a darker green. Okay, we'll do a 1 by 3. So a 1 by 3 is also look for our dots. Okay, so in this scenario, a 1 by 3 grouping, what we're doing is we're looking for 3 terms that you can group together that if you factor it, it ends up becoming something raised to the second power. So there we're sort of on the way here. The problem is that these signs are all off, right? Aren't these signs all off? So can I pull, if I group this together, can I pull out a negative? Absolutely, we can pull out a negative. So that's what I'm going to do. I'm going to go ahead, I'm going to pull out my negative. So then I'm left with y squared minus 10y plus 25. If I have y squared minus 10y plus 25, can I now factor this? Yeah, isn't this the quantity of y minus 5 squared? So then we're going to have x squared minus the quantity of y minus 5 squared. Is this a dots? Absolutely, this is a dots. So now we are x plus y minus 5. But now what should I do with the x minus? What do I have to do? X minus? Danny?
Minus y plus 5.
You got it. We have to distribute in that negative. If you want to put it in parentheses first and then distribute it in, you absolutely can. So this would be an x plus y minus 5 and an x minus y plus 5. All right. The next kind of grouping is a bad one. The next kind of grouping is going to be when it's original 5 terms. So all that was original 4 terms. Now our original is 5 terms. Actually, can we come back to original 5 terms? I'm going to say original 6 terms first. So we're going to do original 6 terms, and then I'll come back to original 5 terms. So when it's original 6 terms, this is called a complex middle. Complex middles are the worst. Okay, so for a complex middle, let's see, did I write out any steps for it? No, I didn't. Okay, so for a complex middle, let's say we have 3x squared minus xy minus 2y squared minus 7x minus 8y minus 6. One, two, three, 4, 5, 6. 6 terms. Okay, so for a complex middle, I'll write it out. We're going to look for a trinomial that can be factored. It's not going to be a perfect square, or it could be a perfect square, but it doesn't have to be. Look for a trinomial that can be factored. Right, like I said, it can be a perfect square trinomial, but it does not have to be a perfect square trinomial. So looking at our complex middle, do we agree if I group these together, I can factor it? Yeah, if I group this together, I can factor it. If I group this together factored, it would be 3x plus 2y, and then the quantity of x minus y. Do we agree these are the same? Michael?
So how do you look for the signs that there's like a factorable trinomial?
So you just visually look at different terms, like three terms that can go together, and you try to factor them. So like for me, this seemed pretty obvious because I had that -2 and the 3. So I looked at like, okay, well, I know when I factor this, that factors of 2 and like with a leading coefficient of 3, I can definitely get to that -1 in the middle.
Could we rearrange?
You can rearrange things if you want. Sometimes there's more than one thing that like you can pair together that can work to factor, and then you can rearrange and it will still work. Anybody confused with how I got from here to here? Did anybody need to see me factor that? You want to see me factor that? Okay. If you want to see me factor that, that's fine. All right, so this becomes factors of 3x, which are just because it's prime, 3x and x. Right, James? All right, so then what we're doing is now we're looking at the factors of -2y squared. Well, the only factors of -2y squared are 2y and y. So now we have 2y and y. We know one of them has to be negative. We're not really sure. So that's when we're going to play around. Let's say let's do it wrong. Let's say I put the 2y here and I put the y here. We would then check this. We would say, okay, well, 3x times 2y is 6xy, and then another xy. Is there any combination of 6xy and xy that will give us a -xy? No, so that means I have to switch their locations. So now I'm going to switch them. So now I'm going to have 2y here and y here, and then I'm going to check it. So 3x times y is 3xy, and then 2y times x is a 2xy. Is there a combination of 3xy and 2xy that could give us a -xy? Yeah, which one has to be negative? The 3. So what I'm going to do is I'm going to put my negative here. Oh, yeah, here. So then it's 3x times -y, which gives us the -3xy. And then this one becomes positive. So that's how I factor that. Are we good with that? Okay. So then we're going to go on and we're going to have -7x minus 8y minus 6. Okay, this is why it's called a complex middle. So you know in our trinomial, when we normally have a trinomial, we are a squared plus ax squared plus bx plus c, right? First term, second term, third term, right? Normally, when we're factoring, it looks something more like this. Okay, I'm going back and I'm going to say, okay, I want to somehow visualize this whole hot mess to, in my mind, look more like this. So what I'm going to do is I'm going to say, okay, well, this is going to be my first term. This is going to be my second term. And then the last number will be my third term. How much time do I have left? 2 minutes? All right, to be continued. All right, we will finish up this lesson next class. No homework.